an earthquake strikes, seconds matter. However, there may be a small window of time that could allow you to receive an emergency alert and find cover. Monitoring equipment around the Northwest is the foundation of the Shake Alert System. As meteorologist Leah Pizzetti with our Environment Northwest team explains, scientists continue to expand that network.
A small box with a big job.
We're tucked away into a lot of janitors' closets or IT closets at schools and fire stations.
Doug Gibbons, research engineer at the Pacific Northwest Seismic Network, shows off this seismometer hidden in a popular place at the base of the Space Needle.
And this is how fast data is getting back to PNSN and being analyzed for things like earthquake early warning and the Shake Alert project.
This is one of hundreds around the Northwest, part of a growing list helping with faster earthquake alerts.
The shaking from that epicenter is going to hit a station sooner if there's more stations. If we only have a handful of stations, that seismic wave may have to travel dozens of miles before it's detected. Which eliminates several seconds of potential extra warning.
The team has been expanding the network through the last decade. In 2014, there were just 240 seismometers around the Northwest. The USGS set a goal of 600 seismometers needed to properly cover the region, so the team has been expanding the network through the last 10 years. Now, there are nearly 700 stations.
The more we know, the more we're learning, the more data we're collecting, the better that's going to be for us right now and for research down the road.
With Northwest metro areas now fully covered, they're working on expansion beyond. Doug and a team of PNSN scientists are preparing for a journey.
We've got water distributed in this trailer, that trailer.
They're taking their monitoring to new heights.
Yeah, it's a complicated process to get these things up on the side of a volcano, especially a volcano as remote as Glacier Peak.
They're upgrading the single outdated seismometer on the mountain.
What's up there right now is kind of like a black and white TV, and we're putting a 4K TV up there.
This upgrade is years in the making. The scientists hike while a helicopter drops off the equipment at the top. With locating the location of a quake, 3 stations are needed to triangulate which direction the shaking is coming from. The closer the stations are to each other, the more accurate the reading. Volcanoes like Mount St. Helens and Rainier have about 20 stations each, giving detailed information on the exact timing and locations of quakes there. On Glacier Peak, the current closest stations are miles away in Leavenworth and Darrington. The goal here is to add at least a few more seismometer locations to Glacier Peak to better understand this mystery.
And Glacier Peak hasn't had really any locatable seismicity over the past 30 days. And is that because there's no seismicity, or is that because we don't have enough instruments to locate those little earthquakes?
It's not just expansion at the highest elevations, but also the lowest. Right now, 100% of monitoring stations are on land, so scientists are working to add underwater stations off of Oregon's coast in 2026. They'll be plugged in using underwater cables and will further help improve that early warning system. For Environment Northwest, I'm meteorologist Leah Pizzetti.
And to see all of our stories in our When the Earth Shakes series, all you got to do is text the word SHAKE to 208-321-5614. Tomorrow, we're going to hear the science behind tsunamis and the relation to tectonic plates.